3.
Okay. And so if we want the 10th term, that tells you the value of n. N is 10. So go ahead and calculate this for us, please. And let me know what you come up with.
Uh, 9, 98415. I'm trying to think.
Good. Yeah, 98,415. All right. Is that so I was asking if you got a reference sheet for your test. If not, you might want to write this down. Might make a note that A1's the first term, R is the ratio between terms, and so on.
Yeah.
All right, let's keep going here. Number 5. All right, what is the greatest common factor of 12x to the 4th plus 8x cubed plus 20x squared? You start by looking at the 3 numbers, 12, 8, and 20, and you want to find the largest number that goes into all 3. Four. I agree. It's 4. And I think that's all they're looking for. I would recommend doing just a tiny bit more here for that. Well, I'm sorry. There's a bit more here. My apologies. Next, you look at the variables. So you look at the x to the 4th, x cubed, and x squared, and you want the one with the smallest exponent.
Yeah.
Or x squared. And then you're gonna divide each of these by that GCF. So that's how you figure out what goes in parentheses. So I know it doesn't ask for it, it just asks for the GCF, but do you mind telling me what goes in parentheses here?
Sure. Three x squared plus 2x.
Good.
Plus 5x.
Just 5.
Oh yeah, just 5.
If it was 5x, then these would combine, and then when you're done with your inside parentheses here, they still shouldn't combine. All right, but in terms of your answer, it's just the 4x squared. That was just a little extra piece that we might need in another problem. We'll see. All right, start with number 6. Go to number 6 now. The when you're simplifying here, you're trying to decide, well, do I need to do anything because there's parentheses? And the only time you need to do something when there's parentheses if there's a minus or a number in front. There's no minus here. There's no numbers in front, so you can completely drop the parentheses. Like that. And so next you will combine like terms. (7x squared plus 2x squared). You'll combine the 3x and the minus x, and then the 6 and the positive 4. So if you could tell me what the final answer is.
9x squared plus 2x plus 10.
Okay, good. And this is in standard form. Standard form means descending order. Like the exponents go down 2 to 1 to 0. That's what they're looking for. We haven't seen any that are rearranged, but I guess wouldn't put it past your teacher to do that on a test or a quiz. Okay, so number 7, kind of the same deal here, but this time you do have a reason to hold the parentheses. You got this negative in the middle, and that applies to both terms inside parentheses. So it's minus 7x cubed minus 5. You change the sign. Change the sign.
So it's 3x cubed plus 3x minus 5.
Yep, you got it. So 8, 9, and 10 are missing instructions. They probably should tell you to multiply. Because you might actually try factoring this, which I actually don't know if it does or not. But the 8, 9, and 10 are to multiply. So this 5x cubed is going to go to each of these. So give that a try. If you have questions, please ask. This is a review, though. I think you know this pretty well by now.
I got 15x to the 5th.
Good.
Plus 5x to the 4th.
It's 25. 5 times 5, 25, x to the 4th.
Okay.
How about the last one?
And 20x to the 3rd.
Very good. Great. That's good. Excellent. You can do that on your own. Number 9 here, you're going to FOIL. So give that a try. You will combine the O and the I when you do this.
Yeah. Uh, 4x squared plus 14x minus 8.
Good. Really good. Okay, now 10 is this classic problem where if you don't write it the way that 9 is written, you will do it wrong. You have to, you really literally have to write it out, x plus 8 times x plus 8. And then you say, oh yeah, it's just a FOIL problem. It's just like the last one.
X squared plus 16 plus 64.
16x.
Oh, yeah, 16x.
All right. How do you feel? We think we're done with that side of the sheet.
Yeah.
Pretty clear.
Yeah.
Okay. 11, 12, 13, and 14 are factoring problems. These are, we really spend a lot of time doing this type of problem. So I'll obviously give you some hints here, but you always first look for a GCF. And that's what this problem has. It for sure has a GCF. So we did one earlier like this. Look at the numbers, look at the variables, see if you can tell me the GCF, please.
9.
A little more.
Oh yeah, 9. 9x.
9x, yeah. Okay, and then that's only part of it. You got to figure out what goes in parentheses. So go ahead and divide and tell me what you come up with, please.
X minus 3.
Good. Now, if you have time on the test, you can multiply in. You could do 9x times x minus 9x times 3, and it'll give you 9x squared minus 27x. This is your check. If you have time. I would do all the problems and then decide, how I felt afterwards. All right, so new problem here. This also has a GCF. So go ahead and look at the number first, then the variables.
Yes. It would be 3x.
3x squared. So you look at the smallest
Oh,
exponent between them. I'll probably do another one like this. You look at between the x cubed and the x squared. You similarly have to look at the y's. What's the smallest exponent between them? See how there's a 2 and a 3.
Yeah.
You want to choose the smaller one. Okay, so you're gonna divide each of these by 3x squared y squared. Tell me what you come up with.
I have x y minus 4.
So we got, yes, so it's y plus, so that the 3x squared are the same, the y cubed or y squared becomes the y, and then just x in here with the 4 in front. I might have heard a minus, I'm not sure.
Yeah, minus.
Okay, so it stays positive, keeps the sign there. This one's pretty tough. We really haven't looked at many like this, so I'm gonna just not consider it to be like normally I would think, well, let's do another problem like it, but unless you think it's going to be on the test, we should just move on to 13. But if you do, I can give you another one like this. What do you think?
Let's try another problem.
Okay.
Like this.
Okay. Let's go 4x cubed y squared z. Let's just do that. plus 8x squared y cubed. Okay. So same thing, GCF.
Um, 4x y.
Like this.
Yeah.
You when you look at the x's, you choose the smaller exponent. Same with the y's.
Oh yeah. So x2, y2.
Yes. So let's have you do another one here. I'll make this one a little harder just to us. So we got 3x to the 4th y cubed z squared minus 6x squared y cubed z to the 4th. So just the GCF, please.
3 x squared y cubed
Okay,
z squared.
good, really good. All right, let's move on to number 13.
All right.
So you always start with the GCF. And in this case, the GCF in this new problem is 4x. You go through the numbers, you go through the variables, and then you divide each of these by 4x. So that's 5x squared plus 4x plus 1, like this.
Let's see.
Okay, now this is where it gets like a little dicey because you're supposed to try to factor this one. It actually is unfactorable, so I'm not sure what the intent was here. But if you remember, when the leading number isn't 1, you multiply the 5 and the 1. You get 5. And you're looking for two numbers that multiply to 5 but add up to the 4. But 1 and 5 don't add up to 4. And neither do -1 and -5. So this is done. This is totally done. But usually you have to keep going. You have to say, well, maybe I can factor the next thing, and the next thing, and the next thing, and so on. All right, so let's take a look at 14. So 14 is not really related to the previous ones. It is a factoring, but it's grouping problem, factor by grouping. And the thing you're looking for with grouping is it usually has 4 terms. It's usually got a power of 3 or more in it.
Yeah.
So if you recall, you look at the first 2 terms and you find the GCF of the first 2 terms.
3x squared.
Yes. 3x squared. And then you figure out, well, what goes in parentheses. I'll let you give me that answer.
X plus 4.
Good. And then you immediately write that over here off to the right, x plus 4. What goes in front here such that when you multiply in, you get back to the previous line?
+2.
+2. Yeah, so this becomes x plus 4 times 3x squared plus 2. We've done a bunch of those. Some of the factoring turns into this grouping where you have to do it this way.
Yeah.
All right, so it looks like you do not need help with 15. 16 is the next one that I'm seeing. Is that right?
Yeah.
All right. 16 is just, it's a previous part of the course, not really related to anything we're doing. It's a formula. The function is, or the formula is, the amount in the future is the principal 1 plus the interest rate divided by the number of compounding periods to the power of the number of compounding periods times t. And they typically give you all but one of the values. So they give you p, they give you r, they give you n, and they give you t. So could you look this over and give me each of those values, please?
So P is 7,000.
Good.
The rate is 5.2%.
So you never, yeah, you got to convert it to a decimal. What is that decimal?
0.052.
Good. The n comes from the word monthly.
Be 12.
Good. And the balance, or I'm sorry, the number of years?
Yeah, 6.
6. Grab your calculator, see if you can work this out. And you're rounding to the nearest cent, so 2 decimal places. Sometimes it is good to write it out before you put it in the calculator. It's up to you if that's what you're going to end up doing.
Uh, 9,556. 0.64.
Good, really good. So again, you probably need to know this formula. Write it down. Look at it, stare at it. I don't know. Just there's no way to do it without that. All right, so we'll move on to 17 next. All right, write a polynomial in standard form that models the area of the shaded region. So what I see here is you've got a large square or rectangle and subtract a little rectangle. And sometimes it's good to make 2 different drawings to see that, 2 different shapes. And then just relabeling it. So y plus 4, 3y plus 4, y and y, like that. So how do you find the area of the larger one?
Multiply base times height.
Okay, so y plus 4 times 3y plus 4. The order doesn't matter. Height times base times height, it's the same thing. And then the smaller one, which you're going to subtract, is y times y, or y squared. Okay, so what I want you, so what I want you to do here is FOIL this and then subtract this and let me know what you come up with. I'm going to just step away for 30 seconds, but I'll be right back.
All right.
All right. I'm back. Do you have any questions? If not, just keep working on this.
All right. I have 2y squared plus 16y plus 8.
Did you say 8?
Yeah.
So remember that when you FOIL, last times the last gives you.
Oh yeah, wait, it's 16.
Yes.
Yeah.
The rest of it was really good. Would you say the details kind of get you in a lot of these assignments? Yeah.
It's the little things.
Pretty good overall. I mean, that kind of question's tough for most students. Really just but just keep in mind separating them out is really key to doing that. So all right, I think that takes care of everything on the paper. Is that everything you wanted to look at there? We can move to the screen.
Yeah.
Is there one you want us to start with on the screen?
I believe number 1 is there.
Yeah, I don't, so I'm not, I see like, I'm guessing this is the first one. How could you use special factoring to rewrite the 50 squared minus 45 squared? Is that the first one?
Yeah.
Okay. Yeah, I don't have any numbers on there on mine.
Oh, there. I probably didn't keep
Or I can't see them. All right. Are you excited for the Super Bowl this weekend or don't care?
I don't really get the hype of.
How about the halftime show? Is that important to you?
They have funny ads.
Funny ads. Okay. There's always something for everyone. All right. This problem here, they're trying to show you, give you like a numerical explanation for this. So and there's TikTok videos out there on like how people can really fast, square two numbers and find the difference. They're actually just using the formula that we're about to see. So the formula is a squared minus b squared equals a minus b times a plus b. And in this problem here, a is 50 and b is 45. And you might think, well, why would I ever do this? I mean, I just throw this into my calculator and give me a number. It's like this leads to the next thing that does not have numbers that you have to use the formula for. So in your problem here, it's 50 minus 45 times 50 plus 45.
Yeah.
All right, so that's probably the first box, something like that. And then in terms of like how someone does this real fast, they know this pattern, and then they say, oh, it's really 5 times 95. And they can quickly do that calculation to give you a result here. Full disclosure, how do people do that fast? They look at it as 100 minus 5. And so, I'm sorry, that should be a 5, not a 50. And so they recognize, oh, it's 500 minus 25. Let me write that out here. And this used to be important. Like if you didn't have a computer, didn't have technology, like maybe this mattered, but now we who cares, because we just do it by hand. I mean, CD collections used to be a thing, and now we're all on Spotify, or if you're old, you're on Pandora, right? So it's kind of like they're leading to something. It's just they're using this as an example.
Yeah.
Do you have any math videos come up in your social feeds? Guessing probably not.
Yeah, probably not.
Okay. I thought I saw another one here. We should do this factor completely, t to the fourth minus 81 next, because it's the most related to this.
Okay.
Or r to the fourth looked like a t on the screen. It's an r to the fourth minus 81. So this is again difference of squares, even though it's not squares, it's bigger powers. So you ask yourself, well, what squared gets me back to the previous line? What squared gets me back to the previous line? Sometimes the number's easier. What squared gets you back to 81?
Nine.
Okay. And then r to the fourth. This may be, I'll give me a try. What goes in here such that when you square it, you get back to r to the fourth?
R to the second.
Good. Good. Very good. Okay. So this is what's inside parentheses is your a and your b. So I'm going to just rewrite it off to the side here. Sorry, let me do this one more time. R squared minus 9 squared. This becomes r squared minus 9, r squared plus 9. Okay, so now on the left, this left one is difference of squares. Can you try using difference of squares for this one and tell me what you come up with, please?
Sure. Okay, r to the fourth minus 81.
Okay, so
Wait.
you just went backwards.
Hold on.
So
Yeah.
that's like when you make 4 right turns.
Yeah.
You go all the way back. I didn't. So what I was hoping, was trying to get you to do is see that this one right here is the same thing. It's, you can write as something times something because it's difference of squares.
So the r times r and wait.
Let's just break it up over here. What squared minus what squared gets you back to the previous line?
R and 3.
Good. So that's your a and your b.
Yeah.
So you're going to write a minus b, r minus 3. And what's the other one?
B. So
Sorry, I guess I never wrote it.
R plus 3. Yeah.
Yes. Okay, let me give you, so I'm sorry. So in terms of the answer, you bring the r squared plus 9 down. That's your answer. I want to give you just a few quick examples to try. that are not this complicated, but that's your answer here for this one. So let's have you try this one. X squared minus 4. And I'll write the formula up here. A squared minus B squared, A minus B, A plus B. Go ahead and give this one a try, please.
Okay, so x and minus 2. And then yeah, so x minus 2
Good. What goes in the next position?
and x plus 2.
Good. Really good. Okay, let me have you try another one here.
Okay, y minus 5 and y plus 5, I think.
Yep. Yep. See, that was so much faster than the previous one. Let's do another one here. Let's go x squared minus 100.
X minus 10 and x plus 10.
Good. Good. Okay. Let's keep going with the rest of your assignment. See if we can get everything finished there. Are these due today, or are you a little ahead on this?
This is due today.
All right, clock is ticking. Okay, well, the next one here is just like what we've been doing, just more difficult. I'm going to write it off to the side here. I think it'd be a little easier for us to look at. Just like the previous problems, though, you have to figure out, well, what's squared minus what's squared. You have to figure out what goes in parentheses. So you look at the number first, like what do you square to get to 16?
4.
4. And how about to get to x squared? X, okay. 169, to get back to 169 is 13, and then y. So again, this is your A, this is your B. Tell me what to write here, please.
So okay. X I want to say x minus 16, but
it's always this A minus B, A plus
Oh,
B.
yeah.
What is your A? What is your B?
Okay. Four x squared. So
So just the 4x minus, and what's the b? It's just what's in parentheses.
Yeah, 13y.
Okay, and then what about the other position?
4x plus 13y.
Yes, perfect. Okay, good. All right, so let me really quickly do the last two here, just so that you've got them for your assignment. I apologize, this was kind of rushed at the end. I thought we were gonna have plenty of time, but it didn't quite work out. So this one has a GCF. This one does not have a GCF. This is a perfect square trinomial. So you take the square root of the first and the last, which is 5x plus 6, and that becomes your answer. You just take the square root in the first and the last. Okay. And then again, really quickly here, we're running out of time. Give more explanation like next time if you want. But this is a related problem because the perfect square trinomial, you're trying to figure out the number that goes here. So if we go back to the previous problem, the last number is related to this middle number in a certain way. So you actually, I don't want to say this, well, this isn't a good example. So I'll just give it to you here. You take half of this number, you cut it in half, and then you square it to go back. So this is your answer here for that, wherever the box is. We can cover that, next time. I hope that's not on your test because we really hadn't spent much time on it.
Yeah, because if it was assignment from today, it's probably not gonna. Hopefully, not gonna be on the test.
Yeah. But if you have time, I would recommend reviewing some of the problems that we worked on today, and then the other